Hi, in this video we are going to discuss 7 essential and very popular data structures at a high level. These are part of almost every technical interview that you give for a software developer position. A staggering 83% plus questions will directly or indirectly use one of these data structures. I'm going to talk about the details of each data structure, operations that can be performed on each of these, the applications of these data structures. We are going to go through illustrations, and I'm also going to talk about the complexity at the end. So sit back, relax, and enjoy the video. The first data structure is array. Array is a linear data structure. It's a collection of items stored at a contiguous memory location. The idea is simple. It is to store items of the same type together at one place, and each of those are accessing some kind of a memory location. Array elements are accessed using index. The first element of the array is indexed at 0. There are different operations possible in an array like searching, sorting, inserting, traversing, reversing, and deleting an array. An array is also used to implement other data structures like stacks, queues, heaps, hash tables, etc. The time and space complexity of an array is insertion and deletion in an array for an worst case is O of n, and access and search, access is O of 1, and search is also O of n. Space complexity is O of n. The next data structure that we are going to talk about is linked list. Linked list, as you know, is a very common data structure. It's a linear data structure in which elements are not stored at contiguous memory locations like the array. Elements are stored at different parts of the memory. Each of these elements are called nodes. Nodes in a linked list are linked using pointers. Thus, each node has specifically two attributes: a data node and a next pointer to the next node. The first node in the linked list is called a head node. Linked lists are used to implement stacks, queues, graphs, etc. There are various types of linked list also, like singly linked lists, doubly linked lists, circular linked lists, doubly circular linked lists. The time and space complexity of linked list, the insertion and deletion of a linked list is O of 1, that is constant space. But access and search is O of n. The space complexity is also O of n for a linked list. The next data structure is stack. A stack is a linear data structure containing the top and the bottom of the stack. It follows a particular order in which the operations are performed. When an element is inserted, it's called push. And when an element is deleted from the stack, it's called pop. Insertion and deletion happen at the same end in the stack data structure, if you notice. It follows the LIFO order, that is the last in, first out order. So if you want to remove an element from the middle of the stack, you have to first remove all the elements on the top of it from the stack to then remove that element. Stack data structure is used in evaluation and conversion of arithmetic expressions. It is used in recursion. It is used in parenthesis checking. So stack, it is used in computer tracing. So stack data structure has a lot of applications in the real world. The time and space complexity of a stack data structure, the insert and delete is again O1, but the access and search is O of n, which are worst case. Space complexity is O of n for a stack data structure. The next data structure is queue. Queue is also a linear data structure which has a rear and a front end. It follows a particular order in which the operations are performed, where inserting an element is called NQ and deleting an element is called DQ. NQ happens from the rear of the queue and DQ happens from the front of the queue in a FIFO order. FIFO, that is first in, first out order. In a queue data structure, insertion and deletion happen at different ends, unlike the stack data structure, if you notice. So to remove an element which is at the last or at the rear of the queue, all elements inserted before it in the queue must also be removed. Queues are used to maintain various playlists in a media player, job scheduling in operating systems, sending an email. Emails are queued before it is sent to the recipients. A more real-world example can be seen in a queue at a ticket window counter. a person joining the queue at the first will move out of the queue also at the first. The time and space complexity of a queue data structure is the insertion and deletion happens in O1 time, that is constant time. Access and search is O of n. The space complexity is also O of n. So that's a queue data structure. Up next, we are going to discuss three more interesting and widely used data structures. So stay tuned. Now we are coming to the interesting and more widely used data structures. The first one here is the hash table. Hash table uses a technique called hashing, or the process of mapping keys and values into the hash table. Each key value pair is called a record. The mapping of keys and values happens by using a hash function to compute the index where these key value pairs will be stored. This index is also called a hash code. This is done for faster access of the elements or of the records. The efficiency of mapping depends on the efficiency of the hash function that is used. Hashing is used in several real-world applications like database indexing, caches, etc. The time and space complexity for hashes insert and delete on average takes O1, that is constant space. In fact, search also takes O1 for average case, but for worst case, those are On, because it can be a skewed hash table and all the values, key value pairs that you are trying to map can fall under the same index. If that becomes, then it becomes specifically a skewed hash table. In that case, the worst case would be O of n. The space complexity for a hash table is O of n. The next data structure that we are going to discuss is a tree data structure. It is a nonlinear and hierarchical data structure where the elements are arranged in a tree-like structure. In a tree, each node contains some data, and the data can be of any type. The topmost node is called the root node of a tree, and two nodes are connected via an edge. Two nodes which are directly connected as children to the same node are called siblings. The nodes at the bottom which don't have any other children are called leaf nodes. Every tree has multiple levels. The longest path from the root node to a leaf node is called the height of the tree. There can be multiple other ways also to access different parts of the tree, like this is the right view of the tree. A tree also contains subtrees with parents and children itself. Different tree data structures are quicker and easier to access based on the different kinds of data structures that are used. There are different types of tree data structures in itself, like binary tree, binary search tree, AVL tree, B tree. Tree data structures has various applications. For example, in game development, it is heavily used. It is used for domain server names, domain name servers, that is DNS mappings. The time and space complexity of a tree data structure for insert, delete, access, and search, it takes O log n for average case, but in worst case, it does take O of n. The space complexity is still O of n for a tree data structure. The next data structure is one of the most interesting data structures, which is called a graph data structure. A graph is a nonlinear data structure that consists of vertices and are also called nodes and edges. It consists of a finite set of vertices and set of edges that connect a pair of nodes. Some graphs can also contain self loops. To go from one vertex to another vertex, we have to traverse and find a path like this one. From node 2 to node 6, we'll traverse to this path. However, there is also another path which is shorter than this path. If you want to go from 2 to 6, that path is that path, and this path becomes the shortest path to go from 2 to 6. So while there can be multiple paths to go from one vertex to another vertex, several of the algorithms primarily use the shortest path. Graphs are used in social networking sites where every person is a vertex and all friendships are edges, which form the entire network. Graphs are also heavily used in maps like Google Maps, where every place is a vertex and the paths connecting those places are edges. The time and space complexity for graphs, it depends on various operations, like there can be adjacent list, there can be different kinds of shortest path algorithms. So that is, but the space complexity is definitely O of n, and the time complexity will be dependent on the type of algorithm that you are applying to the kind of problem that you are solving. So these are the most common data structures, and these are also the most popular. We are going to discuss more such topics, so don't forget to subscribe to our channel, Software Dude, so that you don't miss out on those videos. Hopefully this was useful. Let us know in the comments section below if you liked it. Thanks for watching.